Our very first fresh pressed live.
How exciting.
Does it feel different than how we do it now that we're live?
Well, right on.
And why don't we get it started? Pasteurizing. So if people are in the US, there's three, right? It's heat, light, or no pasteurization. Is that how you put it?
Yeah, I mean, you may be in a state where farm gate sales are something that's permitted, and you're able to retail raw juice direct to consumer, maybe with a warning label, but definitely not something we see up here in Canada, but something that our folks in the States may be able to do depending on where they're at.
Perfect. So why don't we start off so we can have a nice intro. Hello, everybody. Welcome to Fresh Press Live by Juicing.Systems. I'm Alex. I'm joined by Nathan, our sales lead here and juice processing expert for today. Today, we're really unpacking a topic I think every juice cider producer need to understand that maybe don't fully, which, like we said, the three main ways that we can process juice, especially in the US. In Canada, you have to pasteurize. But in the US, you can sell it raw. You can use heat or UV light to pasteurize. Our goal right now is, I think we'll talk about what each one means, especially for your business, for your product, your quality of the product, and the equipment choices that you need to do these type of pasteurizations. And Nathan will share some of the field stories that for the past couple of weeks we can see how the world in juice equipment is going. So something very broad. When we talk about juice pasteurization, what are the main three ways we can go about to do it in the US, and then obviously the two in Canada?
Yeah, absolutely. So I mean, like we kind of touched on there, raw juice sales in the US are regulated state by state, and you may be in a state where you're able to press juice fresh and sell it without pasteurization. Now, that could be like a juice bar kind of thing, or going to an orchard where they press sweet cider on site and maybe serve it by the glass or serve it for off sale, on site consumption, that kind of thing, but with a warning label on the packaging. Obviously, from an equipment standpoint, you just need the press and a good, clean work environment to be able to produce in this fashion. Of course, risks are higher than if you have some sort of pasteurization process that is going to achieve a kill step or a 5-log reduction. This is a phrase you'll hear us use a lot today, of your pathogen load. And just to define that right out of the gate, a 5-log reduction is considered a 99.999% reduction in the microorganism count. So if we're concerned about salmonella, E. coli, listeria, these kind of things are typically what we run into with an acidic juice like apples. That is kind of what we're targeting, whether we look to do that with heat or UV light, or at a very high production scale, more of a commercialized type thing. There's also ways to do it with pressure, called HPP, which is high pressure processing, where you submit the juice to tens of thousands of psi of pressure inside a very specialized and very expensive machine.
Let's take it by steps. So why don't we first dive in a little bit deeper? In obviously, the first option is raw. Like, you can leave your juice how is in the US. I mean, depending on the state, obviously, do your own research if that's possible. What are the main risks that you see when people are taking that path?
Well, those are the risks. Is really to oversimplify it, that you make someone sick, or that someone gets sick from consuming unpasteurized juice. That's why you have to sell it with a warning label. That is, really, you're counting on the fact that you work incredibly clean and the juice is consumed before those microorganisms that we're concerned about, again, salmonella, E. coli, listeria, cryptosporidium parvum, these kind of things, have a chance to replicate to the point where they're at a level in the juice that could make someone sick. And so it's as simple as that, really. If you're going to be producing juice in this way, it's important that you make friends with your local health inspector, that you understand what they're going to want to see to be happy with your operation. They're going to be the person who has the final say in how your, licensing for this is going to go. And so you want to make sure that you have everything they want to see to be happy with that. And one of the big things that they'll probably ask for is your HACCP plan, or hazard analysis critical control point plan, where you lay out what you're doing to ensure that your equipment is clean, it's been sanitized, you're producing in a way that, is using sorted fruit, that's not ground fall, that is as low risk as possible.
The next step, if we want to keep it simple, would be thermal, right? Pasteurization through in a thermal or heat, applying heat. So basically using heat, which is, would you say, like the traditional method? And what could you tell us about that, understanding that method?
Sure. Yeah. I mean, it certainly is the traditional method. I mean, if you go to Louis Pasteur, the guy who kind of came up with the process, initially more for dairy applications, but to increase food quality, heat has been the way it's been done. And it's important to just note that pasteurization is broadly processing this juice in a way that achieves a 5-log reduction of the pathogen of concern. If we just take it to its simplest sort of standpoint. So all of these technologies we're going to talk about are going to be done with that goal in mind. That's the desired outcome, is that we kind of get a clean slate here to start from. How we
And
handle
then,
it after, I'm sorry, go ahead.
yeah. I mean, this is just, we're going over quickly abroad so we understand it. If we jump to UV pasteurization, which is light pasteurization, what's the principle behind that, and why are we seeing more producers move towards that?
Yeah, I mean, since the technology emerged, I think that, it's accessible. It doesn't use any sort of heat, so the sensory impacts on juice are pretty much negligible. Like, there's a bit of heat from the juice being pumped and passing by some big UVC lamps, and that's basically what happens. Is the juice is pumped through a reactor, if you will, where there's a bunch of UVC lamps that basically, to keep it as simple as you can, sunburn the bacteria to the point where it damages its DNA, and it can't replicate. And so instead of using heat to do this, we use UVC light, and the impact on flavor, especially with lighter, more delicate juices, like not really as much of a concern with cider, but with, things like pear or grape, that kind of thing, definitely a negligible flavor impact. Whereas with thermal processes, you, depending on how you do it, and we'll get into that, can see some impact on flavor.
After this, I do want to get into the machines itself. Like, there's a lot of equipment that does thermal and UV light, and I'd like to understand those a little more broadly. But can we touch, like you said in the beginning, um, maybe people have heard HPP, it's HPP stands for high pressure, what's the last P?
High pressure processing, or high pressure
Process.
pasteurization. Yeah.
So that's a little bit of a something going along that maybe we don't understand. Can you briefly touch it and at a high end and let us know why we believe it wouldn't be the best method to explore for juice for this practices, like cider, apple juice?
Yeah, of course. So HPP, basically, you are placing your product in a bottle that then is loaded into a capsule. And this capsule is put inside a machine, an HPP machine, or a hyperbaric chamber. And then it is subjected to about 60,000 to 90,000 pounds per square inch of force. And in doing this, they are able to deactivate the microorganisms that we're concerned with. The cost of the machine is a pretty appreciable barrier for something like sweet cider, which is typically sold in bigger volumes. It's really common in the cold pressed juice industry, where you see, smaller packaging formats and really detrimental effects of thermal pasteurization to certain types of juice. Like green juices don't do super well with it, for example. Some citrus juices see a flavor impact depending on the citrus fruit. And so it comes down to people do it out of necessity, I think, for quality and also to avoid using any type of heat. So it's a very expensive piece of equipment. Typically, people send these to a tolling station where someone has bought this and contract pasteurizes HPP's juice for a fee per bottle or per unit. And if you don't have one of those right beside you, the cost of transporting juice back and forth can be appreciable.
Yeah, we're saying expensive. Can we give them the people like even it's a broad range? Obviously, depends. You're buying it from China. You're buying from here. You're buying who is your distributor? Can we give them an idea so they can actually understand why we're saying the word expensive?
A foot in the door price is probably north of $250,000.
And I'm guessing that $250,000 is not going to be a massive machine. It's going to be reduced quantities that you can put into.
Exactly. Yeah. And because it's a batch process, a bit labor intensive, and for higher throughput applications, something inline like a thermal or a UV unit could be much more economical in the long run.
And we'll cover that. We'll cover the model so you guys understand, and you can have a general idea. Perfect. We covered HPP. We kind of understand that maybe it's not the best choice for a cider business at the moment. Can you walk us through in some simple terms how UV pasteurization treats juice? I know we kind of covered it a little bit, but anything else you could add so we understand it? Because like I say light, okay, like which way is it in the bottle first? Is it like what's the process there?
Absolutely. So UV pasteurization works best with clean, low pulp juices. One of the big things with most UV pasteurizers out there, there are some that are the exception to the rule, and we can maybe go down that rabbit hole in a bit, but generally speaking, you need to have like a settled filtered juice with minimal pulp because you need that light to be able to shine through the juice to effectively get your pathogen kill with UVC pasteurization. This is typically done in line. So before we go into a bottle or a jug, ideally from tank to sanitized tank or tank direct to filler, depending on what kind of setup you have, you are probably going to see up to a few weeks of added shelf life versus a raw product, depending on how you pack and store. But it is going to be something that needs to be kept in refrigeration. What it is doing is getting that 5 log reduction at the time the juice passes through the UV pasteurizer. So as soon as it leaves that chamber where the UV light's hitting it, it can pick up any additional microorganisms that might be in a hose, in a filler, in the air, in a jug. And so you wipe the slate clean, but you start the clock again, really, if there's any sort of potential contamination. And so keeping it refrigerated or adding preservatives are options you can use to further extend, but it's not going to give you a product that can sit at room temperature on a shelf for a really long period of time. It's beautiful in its simplicity. These machines do require revalidation periodically. You need to make sure you're sending off a sample for testing, or with certain machines you have to send them to someone to actually validate the machines themselves. They don't offer a lot of flexibility outside of like a really clear pasteurized juice, but they do what they do and they do it well.
As a comparison, then thermal, how does the process differ operationally?
Operationally, there's two types of thermal that we should talk about. And really there's one big difference to that. There's HTST, or high temperature short time, or flash pasteurization, where you heat product up, you hold it at a temperature that is lethal to those microorganisms for a certain amount of time that ensures we get that 5-log reduction. And then you recool the juice very quickly back down to within maybe 8C, 14 Fahrenheit, 15 Fahrenheit of where it comes into the unit. And you typically run this from tank to tank, and then you fill it and you keep it refrigerated. And your shelf life is pretty similar to UV. The big difference there is it's not as fussy about sediment because we don't need light to penetrate it. We're heating it up to a temperature and holding it there, and that's doing the work for us. As opposed to UV, you might see some really minor changes to your sensory. So I would struggle with HTST, applied at a low temperature to pick out a really pronounced difference in the taste of cider versus raw, maybe a bit of a cooked note. For people who are real connoisseurs, but that would be the method of thermal pasteurization that's most similar to UV. Again, the goal is kind of a kill at the time. You'll also see people who make hard ciders sometimes do this, especially if they're trying to shoot for consistency in product, because it kills any wild yeasts as well and gives them sort of that clean slate to start from. And then there's your hot fill method of pasteurization, which would be, at a really small sort of home scale, batch based type approach. You maybe do this in a kettle where you heat it up to a certain temperature, you hold it there for a certain time, and then you fill it hot into packaging that is rated for that. And the nice thing about this is it gives you a shelf stable product. So definitely a bit of a sensory change in the juice, but now you've got something that can sit on a shelf. As soon as you're producing larger volumes of juice, more than 50, 100 gallons at a go, you are probably going to want to look at something that is an inline process where it's going to heat it up in a heat exchanger, just like the HTST does, but it's not going to cool it back down. It's going to go straight to a filler into your package and give you a product that's shelf stable. We make a lot of this ourselves in the form of bag and box juice, kind of like a boxed wine, and that is going to give you a shelf stable product. We see 9 to 12 months unopened, unrefrigerated on that, which is pretty awesome.
I mean, if we can connect those two, UV and then the two different types of thermal pasteurization to business styles or products of which one is for best, which if you're doing, you have your agritainment farm and you do, sweet cider, they know which product is best for them.
Yeah, there's a few factors that go into it. I mean, I guess scenario one is probably a business like an agri-tainment farm where all of your customers come straight to you. They come in droves, they spend time on site, you make a show out of pressing the cider, and you're in a state where you can sell raw juice. Your easiest, simplest, no equipment needed method is to sell it by the glass to people raw. Where pasteurization is going to come in is the second you want to distribute that. Or if you have people who want to take your cider home, all of a sudden you no longer have total control over the cold chain for your product. There's a risk that someone's not going to put that cider in the fridge, even if it's not your fault. As soon as that product is leaving your property, your possession, you probably want to have a little bit of peace of mind that you've had a kill step, a pasteurization step in there. And so, again, for this high traffic on-site model, something like UV or high temperature short time thermal pasteurization can work really well because you're pressing, maybe every weekend or twice a week. You've got demand for this product and it's moving very quickly and you're happy pressing to order. That's going to be, I think, the best fit for something UV or HTST because you're kind of tied to pressing, and then having a shelf life on this product and then needing to press again and then having a shelf life on this product. And if you're not moving all the product you're pressing before that expiry date, you're risking throwing away product, having to pull product, and generally want to avoid that in business, right? It works well for some people who distribute locally. I think if you've got, a store in your neighboring towns or cities, or a few stores that want to take your product, you put it in a refrigerated truck out of your cooler, it goes into the refrigerator at their store, then you're in a really good position. But I think where something like hot fill makes a lot of sense, stepping into a bit of a different process, is when you want to widen that distribution, for this particular case scenario. So there's sort of, as it scales out, as you get further from having control over how that product is handled, the more kind of security or surety you want to have. So that's to use your agritainment or fun farm model, right? Other people who may want to use UV or thermal HTST pasteurization would be people who make hard cider. They buy their juice in from somewhere else. They want to wipe out any yeast, anything. People who make sodas with fruit juices in them, may want to be able to get a yeast kill on that juice coming in, again, knowing that they've just kind of had their own kill step. Those would be a few business models where UV or HTST would work really well. There's also a case for very large agritainment outfits, with really high traffic for a hot fill bag and box shelf stable product. And there's a few reasons for that. One, it enables you to sell this cider at a point of sale anywhere on property. You don't have to have a fridge. You don't have to have a plug in there. You just need to be able to exchange people's money for that box of cider, and they can take it home and they can keep it for a while. If you have people who are infrequent visitors, but they want that cider, they don't have to make room in their freezer for it. They can take it, they can put it in the garage, it can sit there for a few months, they can drink it at Christmas time with their families. It's sort of another avenue. And it's not saying that you have to do one or the other. We, folks who do both, and who see increases in their cider sales for being able to offer a shelf stable option alongside the, more traditional style gallon and half gallon jug of UV or HTST cider. A straight to retail, sit on the shelf type distribution model where you're really trying to move bulk quantities of cider, the bag and box or the hot fill can be a really beautiful thing, because it lets you pre-produce a pretty vast amount and then not worry about running that production again until you've moved that product. So it gives you a lot more freedom in your schedule. You're not beholden to pressing every week or every 3 days. You press and realistically can sit on that product for months until it sells before you need to make another production run. This works really well as well for people who maybe don't press, but they have a co-man. So someone who's actually contract pressing for other people, because that contract processor now doesn't have to worry about customers being scared that they might be making too much. They're giving their customer a shelf stable product.
It gives businesses a lot more option if you increase the shelf stable time of a product. Obviously, that means that you have to, grow your business outreach. If you're selling to distributors, if you're selling to, online, and I think that has to do with your business model and what you'd like to accomplish. This information is nice to have as a general knowledge, but definitely you want to speak to Nathan about your specific business, because a lot of this information is general, not specific, right?
Yeah, absolutely. And there's lots of ways we can do this. There's lots of options. There's, machines that are capable of doing more than one thing, like combination hot fill HTST units, and just different sort of ways we can tailor whatever we're putting in place for you to your goals and your growth plans as well.
And one conversation we had before that I think it's really important to people to understand, that this process of selecting the right equipment, and which will lead us to talking about equipment, um, is if you're using thermal means heat, right? Fire or electricity or some sort of heat, and depending on your location, selecting that heat. Well, I'll let you take it away. Selecting the
Yeah,
right equipment means selecting which kind of heat is most available and most financially aligned with your business. and location?
Yeah, it's definitely a consideration. I mean, a certain amount of energy is required to heat your juice or your beverage from whatever temperature it's at to the temperature it needs to be at, and potentially some energy is required to get it back down to a temperature you want it to be at as well. And for people in different states and different provinces, maybe hydroelectricity is really prevalent where you live, and so electric costs are really, really cheap relative to something like natural gas or propane. Maybe you live somewhere where getting permitting for a steam boiler install is really difficult, and perhaps you're in a facility where you already have that, and you're just kind of tapping into something that's already there and running. So that's one of the things we talk about when we talk about setting up pasteurization for you, is based on your goals, what's going to be the best fuel source or the most efficient long-term way for us to set this up for you. And that can be, yeah, diesel fuel, electric, steam, propane, natural gas, just to name some options.
If we go a little bit down the rabbit hole, maybe we can repeat ourselves a little, but just so it's clear, can you tell us the differences between each type of equipment? Batch kettles, tubular heat exchangers, and plate heating exchangers. Like, lay down the map of, for thermal, the different types of equipment that maybe we sell and people can find out there, so they know, they kind of have a general idea of the equipment that they'll see.
Yeah, so when it comes to your heating options for thermal pasteurization specifically, you know, part of that energy exchange is generally that we are using hot water or steam, and there's a heat exchanger involved. So in a kettle, you generally have a jacket that's full of water or heating oil or steam, and that contacts the inside wall of the kettle, which heats up the product inside of it. And so that wall of the kettle we can kind of think of as a really basic heat exchanger. It's made hot from the outside, it heats up what's on the inside, and it does it up to a certain temperature. Ideally, you can set this temperature. Some kettles are just going to be, heat exchange based on the temperature of whatever you feed them. When we talk about inline process or the higher throughput applications that we usually are pairing with the pressing equipment we sell, we can think of the high temperature short time pasteurization, or HTST, as sort of using one technology, which is usually a plated heat exchanger, and the hot fill pasteurization is using another technology, which is a tube and shell or tube and tube heat exchanger. And there's a couple differences. The plated heat exchanger is basically stacks of stainless steel plates with gaskets between them, and they alternate in that you have product, water, product, water, product, water. So you get a lot of surface area in a really small footprint. As the juice works its way through the plated heat exchanger, it's heated up by that water, and then it exits. With HTST, the best systems have a regenerative section to that heat exchanger, meaning that the juice coming in is actually being warmed up by the hot juice going out. So we're doing a big part of that recooling using energy that already kind of needs to be spent. And so what this means is a lot of energy efficiency, like 80, 85, 90% energy recapture. And so that's when we talk about the product going in being, 8 degrees cooler than the product going out, or the product going out being cooled to within 8 degrees Celsius or 15 degrees Fahrenheit of the incoming product. We're actually just using the incoming product to do that. If you need to go colder, you can do that in a tank or with an added section that uses feed from a chiller, but you have a really effective and efficient heat exchange occurring in these plated heat exchangers, and in a footprint that is like a few feet by a few feet for a lot of systems. It's really not huge. They're on a skid with their heating method and everything else that makes them a larger unit, but they're not massive. When we talk about tube and shell heat exchangers or tube and tube heat exchangers, the principle is the same, but instead you've got an inside tube that the juice is pumped through and an outside tube around that that hot water is pumped through. The hot water is pumped from the top down to the bottom, and the juice is pumped from the bottom up to the top. And it is heated up as it travels, generally through a spiral arrangement, just to maximize space savings before it exits hot. The one nice thing about tube and shell is that it is a lot easier to mechanically clean it, to scrub it with something. Plated heat exchanger, you can, clean in certain ways, and we can maybe touch on that in a bit, but you can run a physical cleaning medium through a tube and tube heat exchanger. So any sort of high sugar applications, it makes it a lot easier to scrub out anything that's kind of caking in the unit over time.
I think this leads us to a question, a two-part question. One is being which type of equipment tends to suit juice versus cider, and why? I think we kind of covered it, but I'd love to say it again. And at the same time, which choice of heating method impact, quality or consistency together. So a little more extra points to help people decide and understand what's best for them.
The one big thing that makes a plated heat exchanger maybe not the best fit is if you have a lot of pulp or particulate in your product. These plates don't have a ton of space between them. And so generally there's a tolerance. Maybe if you have product that's bigger than 1.5 millimeters, you risk fouling up that plated heat exchanger and having to disassemble it to clean it much more often, which is tedious. And not necessary given that you can use a tube and tube heat exchanger for that application. So if you have a really thick, particulate heavy, cloudy cider, I'd maybe urge you towards the tube and tube style of heat exchanger, but that would be like an extreme case. I think both work well with both cider and juice. If you're doing citrus juices, plated heat exchanger is probably not the absolute best option just because of how pulp is kind of stringy, unless you're doing a completely filtered citrus juice. But both have their place. The plated heat exchangers offer that really efficient recooling. So if it's an HTST application you want, then we generally lean that way. As far as impact on product quality and consistency, it's more related to the top temperature you reach, and then kind of secondarily to that, how long you stay there. And the big question is, are we caramelizing sugars? Like, are we cooking the sugars in a way that changes the flavor of those sugars? So, when we talk about like a very high temp, hot filled sweet cider or apple juice, are we getting a bit of like an apple pie note almost, right? That's kind of the flavor change that is happening there. It's not undesirable or a bad thing in my mind, but that's sort of the kind of flavor change we're talking about. And again, with more delicate juices like citrus or grape, it can be less desirable to have those sugars caramelized. But in something like sweet cider, it's really not a negative change in my mind. It's just slightly different.
I mean, the next question is, you kind of already covered it a little bit, and it would be cleaning, because I think right now we're deciding of how to choose the right one for the product and what you need to do, but operations is also a big factor. And maybe you already have a press and a filling equipment. How does the process of cleaning and operating and fitting into your existing processing line, how does that factor into the equation and choosing the right equipment? And cleaning is something that you always have to do, and we have to consider the cost, the manual labor cleaning, and how difficult it is.
Yeah, absolutely. I was going to say the good news is if you have a press and or a bottling line, you're already, well equipped to deal with it. You're familiar with cleaning. They plug right in. I mean, honestly, if we're doing a hot fill, you are generally pulling from the tank you press into. Maybe you've settled the juice, maybe you haven't. That's a bit of a personal choice in terms of what you're trying to make, but you're heating that juice up, you're going right into the filler, you're packing it hot. And so, it's all quite in line. the HTST is going to be the same kind of story. A kettle's different. You're going to drain it and scrub it manually, you know. Whereas with these inline systems, generally, they're not something you can get in there and scrub. So when we talk about a high temperature short time pasteurizer with the plated heat exchanger, what you're going to do is usually run from tank to a tank in front of the filler. And then once all of that juice has been processed and filled, you're going to rinse out your initial tank, rinse out the subsequent tank. And then what you'll do is you'll usually take that first tank or a small tank that you've dedicated to the purpose, and you'll fill it up with a caustic solution, usually. Popular option is like sodium hydroxide mixed to a certain percentage, run at a certain temperature. And you cycle that through the unit. And what that does is it breaks down the organic material. So any sugars that might have caramelized, any pulp that might be kind of building up in there, you're going to essentially start this process where you pull in that product, you're running at a certain temperature, and then it's feeding back into the tank it's pulling from. And so you're going to loop that through your system, kind of cleaning it in place while you go and clean the rest of the facility. You wash down your press and your grinder, and you clean out your bottling line. And then after a certain amount of time, that should have done its thing. You're going to flush it with water, right? So you'll drain that product safely that you're using to clean. You'll have a tank of water that you'll then use to flush through it, and you'll go straight to drain with that. You can validate once all that caustic's gone out of the system by measuring the pH of the water coming out and ensuring it matches the pH of the water right out of your tap, because that caustic is, in the case of sodium hydroxide, very alkaline. It will affect the pH of that wash water until it's gone. And so flush it out according to, manufacturer's instructions and your safety plan. And then you can run either just a water rinse or a light sanitizer solution through to put that machine to bed and have it ready for the next use. Drain everything away, and you're kind of set. With the tube and tube heat exchangers, there's an extra step. So you cycle that caustic, you flush it out, and then you can get these little rubber sponge balls. Sometimes they call them hose pigs. There's different names for them, but basically they're just a little bit bigger than the inside diameter of the tube the juice is in. And so once the caustic has kind of broken everything down, you can put these balls in and push them through the tubes with water. And you'll see you push it through once or twice, it pushes out a bit of like discolored liquid, and then you do your same sort of flush process as I explained for the HTST just now, but you've given a physical sort of scrub just to get any last stuff off of the inside of that tube. And then you do the same thing, a flush and validate and maybe sanitize.
How does that affect on your choice? Is it really comparable? Is one easier, harder, more time consuming? Is it comparable?
I mean, depending on usage, you are going to periodically disassemble that plate and frame or plated heat exchanger, and that's going to take some time. You're going to pull it apart, you're going to scrub it, you're going to look for damaged gaskets, you're going to replace any of those. For a lot of people, that's like a once a season thing. For people who are running it all the time or noticing changes in throughput or fouling up of the plated heat exchanger, like you may want to do that more often, but it is sort of an extra step that you don't deal with a tube and tube heat exchanger. But the big trade-off is that you are, if you're using that HTST process, quite a bit more energy efficient.
Right. So you have to consider every aspect, to what you're doing and what your operation is. The footprint, is the throughput, is yes, there's going to be an extra step maybe every season of cleaning, but does that outweigh my equation that it is better, a better equipment for what I need? Obviously it sounds very complex. It sounds like a lot, but that's why we have our team to help those run those equations for you, so you don't have to do them yourself. But if we move to the next question, which is, talking money and dollars and operations, how do these systems, size, throughput, heating, investment, how do they compare to choosing? How would you do the equation to choosing the right piece of equipment for the investment the payback?
Yeah, it's the question most people are concerned with. We've done this enough times that we can pretty confidently, once we understand your goals, help recommend the right technology for what you're looking to get done. The practical side of it, starts with one question, which is, what is the product I'm looking to produce? Genuinely, what is it? Is it sweet cider? Is it juice? Is it something else? Step two is, how do we have to treat it? So what temperature does it need to reach, and how long does it have to stay there for? Once we kind of know those things, we have a really good idea of what we're looking at. And then when it comes to selecting the right unit or determining what the cost is going to look like, the other question is, how quickly or what capacity do I need for this equipment? How much volume do I need to be able to get through it in an hour, in a day? And so as soon as we know, hey, I want to make a gallon jug of sweet cider that's good in the fridge for 3 weeks, and I need to be able to make 132 of those an hour, or 270 of those an hour, or 300 of those an hour, now we can say, okay, here's a piece of kit that will line up with that throughput.
Then I think the last kind of that rabbit hole that maybe you can cover, unless we missed it, is we focused a lot on thermal. Fair enough, because it's a good piece of equipment and method. What did we not cover for UV that we should consider that we haven't covered now?
So I think UV, like I mentioned earlier, you can consider it to kind of be an analog for HTST in terms of what the end product you're able to produce is. The difference being, you're just not applying heat, you're applying UV light, and you need to use a very clear juice. You have to filter your juice. So it kind of limits the style or type of product that you're able to produce. With UV, there's certainly smaller units out there than some of the smallest inline options for thermal. Like, there are some very, very small sort of niche UV options. Once you get into that commercial production scale, though, we're definitely, seeing a capability to go larger with thermal. So on the high end of things, you're going to see there's only systems built for UV that goes so big before you're like installing multiple units and having to mess with that. Whereas you can go very large with a thermal system. The sky is kind of the limit there when it comes to how much energy using steam or large boilers we can apply to heating juice.
Perfect. Yeah. So there's more room to play for growth in the side of thermal and choosing the equipment.
Yeah, as you get to the larger scales, for sure.
Okay. I think you said it, but I kind of want you to say it again. What is the very first question when somebody's thinking, any industry, when they're thinking, I need to pasteurize? What's the first question they should ask themselves to start the journey and exploring the options?
Yeah, I mean, there's pasteurization is often a requirement, not a choice in most cases. And so the first thing you should really start with is understanding what pasteurization means, or what that requirement means for your product. Oftentimes, unless it's something like sweet cider, where there's a lot of guidance out there already, there's a lot of people already doing it, there's established processes for it. If you've got a unique or a novel product, you probably need to talk to a beverage formulation expert or a food scientist, someone who's able to sort of look at what your product is made up of and say, these are the potential concerns, and this is how we can address them with pasteurization. Once you know that, it's just a matter of finding equipment to meet those needs. And there is equipment generally for a pretty broad range of needs when it comes to getting a product food safe or pasteurized or shelf stable, whatever you want to call it. So a good understanding of what has to be done to make your product safe or compliant, is great. If it's something like sweet cider, there's pretty well established industry guidance out there, like from universities like Penn State have done studies that say you can do X, Y, or Z to get this done. So for that, reach out. We can point you towards some of those resources. Your local health inspector should be able to as well. And I'd say connect with them, get familiar with them. They're going to be people that work alongside you. In my experience, none of them are really out to make it difficult. They just need to make sure that things are being done right. And so they're usually willing to help you make their job easier by helping you understand what it is or where you need to start.
How about the second to last question for this segment on pasteurization? Hopefully, it's a huge topic, so I'm sure we'll make more content about it. But if anybody has questions about it, go ahead. Anywhere we're posting this, and you're listening or watching this, leave us a question. We'll make sure Nathan answers to the best that we can. I'm a story learner. Can you put it in all this that we learned into a story? Maybe an example of a past client of like maybe they had a difficult implementation, what we implemented, and what was the outcome. Story time here.
Yeah, I mean, I think one of the examples I used would be of like a customer who had sort of, I guess, hit their ceiling in their sweet cider production in some ways, and basically they were limited in that they had a press that could only put out so much juice, and they had, a system for making a refrigerated product that sold really well, but they only had a couple locations at their facility that they could sell it from, and so it was kind of limited to people coming to that location, taking a jug out of the fridge and purchasing it and going with it. And one of the things that came up when we talked was, that there wasn't a fridge at every till in this business or in this operation. And so we talked a bit about our experiences here with the bag and box cider, the shelf stable cider. And we said, if you get a system that lets you produce both, you're going to be in a position now where you can still make the product that your customers are used to in the way that they're used to it, and that's not going to go anywhere. But at all these other tills, you can now have a couple boxes of cider just sitting there, and if people want to buy them and take them home, you put up a little paper that explains like, this is a shelf stable cider, this is how it's a little bit different from what you'll find in our fridge, and it was a hit, and they saw a really big acceleration in their sweet cider sales as a result of this, because it just got easier for people to buy it, and there was none of the concern of, I have to drink 2 or 3 gallons or 5 or 10 liters of juice in the next 2 or 3 weeks. It was very much I can enjoy this over the next several months. And so that's one example that for me, I think is nice, because it not only helps drive sales for a customer, but it also transforms that consumer experience in a way that lets them sort of take that piece of their visit to this business home and keep that good feeling that comes with like going to the orchard and getting a jug of cider and taking it home and enjoying it, right? Even later on into the year.
Yeah, I like that. And what kind of system did they implement?
They wound up using a hot fill pasteurizer with a bag and box filler, and then having the option to do an HTST on the side of that. It's one of those combination units that I was.
Can you name our exact equipment so we can pop it up and people can see it?
That would be our PAS 2000 with the HTST add-on.
You guys will see it there, so you can see what it looks like, footprint, and all the specs.